Okay, YouTube, in this video we're going to talk about piecewise functions. And so in order to do so, what I'd like to do is just kind of introduce the concept with this, I guess context here. We say a cell phone company offers the following plan that it is $20 per month by 60 minutes, and additional time costs 40 cents per minute. So basically, it's a $20 flat fee all the way up to 60 minutes. And we'll just go ahead and take a look at the graph here. We have, say, time in minutes, and then cost is a function of time. But you can see that we have this constant $20 interval right here all the way out to 60 minutes right here. And then after that, it's going up at a rate of 40 cents per minute. So it's increasing at that rate. But we would consider this to be a piecewise function, okay? Because it can be represented by this cost function as a function of time over here, where we would say that it follows different rules given different values of the domain, intervals of the domain. So basically, we could say our cost as a function of time at first is equal to just $20 if we're on the interval of our domain from 0 out to 60, 0 out to 60 including 60. And then we would say after that, for all t values greater than 60, then what we're going to recognize is it's the initial $20 plus 40 cents per minute times the number of minutes over 60 here. So basically, we have what we call a piecewise function, and it's called piecewise because it is defined by two or more equations over specified domain values, okay? So at times, you're going to see a function that's written this way. We say our function is defined as being this rule, or maybe this rule, or this rule, depending upon what part of the domain we're in. So given this rule right here, what I want to do is this. We say use this function in example 3 to find and interpret each of the following. So if we say, let's go find c of 40. First thing I want to recognize is this c of 40 is actually in this first interval of values here. So if we said, what is c of 40? The idea is that first thing we're going to have to do is look at this input and say in which interval of domain values does this lie? And so our rule is defined as being 20 if it's between, or the time value is between 0 and including 60. So since our 40 here lies in this interval, it means that we're just going to use this rule right here, which says, well, then your cost is just $20. And certainly if I were to do 80 minutes, okay, well, c of 80, we'd say, looking at this input here, 80 lies in this greater than 60 minute category, which means we're actually going to need to use the other rule. So we'll say, well, c of 80 is just this. We say 20 plus 0.40 times our input minus 60, where we're just going to plug it into this second rule since it lies on that interval of domain values. So we'll figure this out here. We say 20 plus 4/10 of 80 minus 60, which is 20 here. And so I'm going to do a little mental math here. We'd say, okay, well, 4/10 of 20, a tenth of 20 is 2, so 4 of those would be 8. So we say 20 plus 8, it'd be $28 in that case. And we could actually go look at the graph here, 80 minutes. We could say, looks like it would be in that neighborhood of about $28. So what I'd like to do before we tune out of this video is talk about, well, how can we graph piecewise functions given some rules? So we have some function here, f of x. And you'll notice that it's defined as being 3, just 3 part of the time, and then x minus 2 another part of the time. And so we say for all x values less than or equal to -1, we're going to have a graph here that is always at a height of 3. Whereas if it's x values greater than -1, we're going to plug in those x values into this bottom rule right here. So what I'm going to suggest is this, that we table values. Of course, we always table values, and it's going to be interesting in this case. We have x and x, but we're going to have f of x on both parts of this. It's still the same function, but different rules. So what I'm going to put over here is f of x equals 3, and over here I'm going to put f of x equals x minus 2. And then what we'll do is we're going to say, well, I'm going to plug in values less than or equal to -1. So this would be like -3, -2, and -1. And then right here at -1, you'll notice this is less than or equal to -1. So what I'm going to draw right here is a closed dot next to my -1. Whereas up here, I'm going to plug in now x values greater than -1, and I'm actually going to start my table at -1. I'm going to go 2 and 3 and maybe 4 here. But next to -1, because I have a greater than, this is supposed to represent that we're going to have an open dot on our graph, because our graph is going to approach the x value at -1, but never quite get to that height. That height is going to belong to this first portion of the graph. So we say if I plug in a negative 3 and our function is defined as this, f of x equals 3, and I say, well, so what's f of 3? Well, it looks like I have no x's to plug in for here. I just don't have any, so it's just going to be at 3. And likewise, if I plug in f of negative 2, I'm going to be at 3. And I'm also going to be at 3 here. So for part of our graph, let's go ahead and graph these points. We say negative 3 comma positive 3 is on our graph. Negative 2 comma positive 3 is on our graph. And negative 1 comma positive 3 is on our graph. Anyways, all x values less than or equal to negative 1 here are always going to be at a height of 3. Whereas if we go to the right now, let's plug in negative 1, and we're going to plug it into this even though it doesn't belong to this rule to kind of see what height it's starting off at. So I'd say, well, what would f of negative 1 be if we plugged it into this second rule? And of course our rule is this, so we'll plug in a negative 1. It looks like we get negative 1 minus 2 is negative 3. So I'm going to put negative 3. If we were to say what's f of, oops, this is supposed to be, I guess we should plug in a 0 here. Sorry, I'm not thinking this morning. 0, 1, 2. Let's plug in 0 because it's the x value to the right of negative 1. We say f of 0. F of 0 would be our input minus 2, where this is 0. 0 take away 2 is negative 2, so we get a negative 2 here. If we plug in 1, I hope you can start to see a pattern here. We get 1 minus 2, which is negative 1. These are all increasing by 1 every time. In this particular case, we get 0 here. So I'm going to go graph all these points. 0, negative 2, sorry, 1. We'll start with negative 1 comma negative 3. So negative 1 down 3. The first thing I want to recognize is that this is an open dot. It would be there if we did include it, but we are not including this because of this exclusion here. And then we would say 0 comma negative 2 is on the graph. 1 comma negative 1 is on our graph. And then we'd say 2 comma 0. And it's just going to keep doing this. And so our piecewise function looks like this right here. So we can see that it's always at a height of 3 up to and including negative 1. But then for all x values greater than 1, negative 1, just beyond that, it's going to follow this other rule. So that's how you would graph a piecewise function. Cheers.